Sorry, just checking that out, seeing if you're with me. Lesson 6-6, scale drawings and proportions. One of the reasons why you need to study about proportions is scale drawings in business. For instance, architects. Architects do this all the time. They draw a house. Sorry, I'm just going to do a floor plan here real quick. If this is like 60 feet by 40 feet, it's a drawing. What do they always have on their maps or on their architectural drawings? 1 inch equals 7 feet. I don't know. Whatever it is on the scale. You have to have a scale. It's so easy. It's so easy to draw things, architects, compared to actually building. That new World Trade Center, the One World Tower, New York City, they had that all designed ahead of time, before anything was ever gone up. Scale drawings. They make miniatures of them so that you get an idea what it looks like before you buy it. Same thing with your house. The architect, they can have it all designed, doors, windows, all that kind of stuff, rooms, so that you can kind of see what it would like before they break ground, before they get any wood there, before they pour any concrete. Scale drawings, miniatures. I don't have a car model, I don't have a train model, same deal. If they say something like 1/16 of a model, 1/16 size, everything is the same look, same proportion, only smaller. Alright? Everything just got a little smaller. Like for instance, here's one of these polyhedron, and I'll give you a close look. Yeah. What happens if I want to make it smaller or bigger? Well, it has to be in the same proportion or it won't look the same. Alright? That's what we're talking about. I'll give you a better example. Here's two of them that are basically the same. These are basically the same. One has a different ratio. These are both stellated icosahedrons, if you want to look at my other website on Mathman Price. 20 of these small triangles, 12 of the big ones, but they're in a different ratio. They're in a different proportion. This length compared to the small one, it makes it look different. This one obviously has a different ratio, longer compared to shorter. It makes it look quite a bit different with different proportions. Same pieces, same idea. If I want to make it bigger, for instance, let's take this one, the red one. It has sides of 10 centimeters and 3 centimeters. So if I was going to make a new one, the ratio on this one is 10 centimeters to 3 centimeters. What happens if I want to make a bigger one or smaller one? Same proportion, same look, just different size. Now obviously if I double it, well then on this one I have to double it also. Go back to your cross product. Cross multiply. 3 times 20, 60. 6 times 10, 60. Alright? It's 60 both ways. If I have an odd number like 15, let's say I want to make it a little bit bigger. By the way, if you double each side, the new figure isn't twice as big. If you double each length, the new figure is 8 times as big. Twice as wide, twice as long, twice as tall. It's not twice as big, it's 8 times. It's 3-dimensional. Alright? If I did want to make this one 15, because I want to make it a little bit bigger, because I only had so much poster board. 10 times what? Well, let's do it this way. 3 times 15, 45. 10 times x, or q, or r, whatever you want to call it. Divide both sides by 10. That means my new side, the new one has to be 4.5. Is that the only way to do it? No. But that takes care of all of them. On your problems out of your book, scale models, bigger, smaller, more than likely it's smaller. Like on the maps, besides the scale drawing for the house, what do they always have on maps? 1 inch equals 50 miles. 1 inch on the map, 50 miles on the regular outline. Or 1 centimeter equals 75 kilometers. We here in America, twice, because we have metric and standard, okay? It's a scale. 1 inch, 50 miles. Let me do it this way. 1 inch, 50 miles. Proportion. They're in proportion. So that everything looks, as we say, normal, just smaller, okay? Scale model, same deal. All of these are either architecture or scale model, and the scale factor. Let's see. We'll worry about scale factor in class. See you tomorrow.